Facebook going as well. Okay, all right. We'll give folks a moment to start hopping in. Thank you so much, everyone. So we're logging in tonight. This is Popping the Science Bubble with Berkeley Public Library. And thank you so much. So our big news at the public library is that we are preparing to open our 5th floor. This is the art and music floor that has our vinyl, our CDs, our art portfolio books. And we're just so excited to be able to open that floor again. So the floor is going to open again on November 7th. Come on up for browsing. This was announced yesterday. So I don't think we've even announced it on social media or email yet, but I did get the go ahead to say something tonight. And on some lights here. Just getting blinded by light. Okay. All right. So just to introduce tonight's program, welcome to Popping the Science Bubble. This is a monthly seminar series that aims to share new research findings from grad students and postdocs at UC Berkeley with the general public and create constructive discussion about a variety of science topics. We have 2 speakers each month who talk about their current research or a topic they find really interesting. The talks happen monthly on the 3rd Tuesday of the month at 5:30 p.m. They're on Zoom now. Hopefully one day when the library gets evening hours, we'll do in person. But it is a great monthly program. The organizers are 2 graduate students from UC Berkeley, Oksana Andrulik and Madison Limmer. And there's also been a history of wonderful Science Bubble hosts. Jenna Tan, you might know, just graduated recently. We miss Jenna, and we're happy the program can keep going. So if you're interested in checking out past seminars, I recommend checking out their website and also the YouTube page. The YouTube page has just a great archive of past Science Bubble programs. Also sign up for the listserv too. There's a fabulous listserv that gives you a message each month about the speakers, and it goes a little more in depth about them and their topic. Yeah, there's just so much. So please check out their website and visit the YouTube page. I will let the Science Bubble team go ahead and introduce their speakers for tonight.
Thank you, Kelsey, and thank you everyone for joining us tonight. Before we start, we just want to let you know that we encourage you to ask questions during the course of the talks using the Zoom Q&A button or the Zoom chat and the comment section on Facebook. And just like Kelsey said, if you're interested in keeping up with our seminars, you can check out our social media or join our listserv. And now we can move on to our first speaker, who is Nico. He grew up near Boston, Massachusetts. He earned his bachelor's degree from Princeton University, where he studied the photochemical reactivity of organopalladium compounds. Nico moved to Berkeley in 2020 and joined the Hardwick Group to work on the upcycling of plastic waste. Outside of lab, Nico enjoys surfing and photography. We are very excited for your talk. Take it away, Nico.
Great. Thanks for that introduction. So you can see my slides? Great. So today I'm going to be talking to you about the chemical recycling and upcycling of plastic waste. And I'll specifically be talking about what's currently being done on this topic and some ongoing research and goals of that research moving forward, including some of my own, specifically on the upcycling of plastic waste. And so to start, I just wanted to, one second, I'm just going to get my laser pointer here. Or are you able to see the mouse? Yeah,
We can
so
see
I'll
your mouse,
just,
yes.
okay, great. I'll just stick with the mouse. So to start, I wanted to talk a little bit about plastics in our lives and how there might be some actual misconceptions about plastic materials, and some, in the sense that we typically think of plastics as just a bad thing in general. But that's actually not really the case. Plastic materials are pretty essential for a lot of aspects to daily life. And I have a few examples of them here. For example, having sterile packaging for food and medical devices is really important for, you know, safety and health. And another potential application for plastic materials is, say, for the automotive industry, a lot of progress is being made towards making plastic parts for automobiles because they're significantly lighter than metal parts. And so for the development of electric vehicles, it's really important to lower the weight of these materials and reduce the overall impact of, say, the gas that's necessary to drive around and whatnot. And to this end, there's a lot of different types of plastic materials. I'm sure you may know that there's not just one single type of plastic. And these different types of plastic materials actually serve different purposes and different applications. And I have a few of them that you may be familiar with listed here. And so I just wanted to talk a little bit about what makes these plastics different and why they can serve different applications, and how that can then lead to how we think about recycling and upcycling these materials. And specifically, these differences in their application has to do with differences of the properties of the different plastic materials. And the differences in these properties actually come from the structure of the plastics themselves. And so to think about what the structure of plastics are, we look at what these materials are on the molecular level. And so at this level, we think of plastics as what are called polymer chains. And so you can think of this as like an actual chain of chain links, whereas instead of actually metal links linked together, these are repeat units of a molecular unit that are actually bonded together. And so these chemical bonds make up the links to make a really long chain molecule. And sometimes these polymers can get up to 10,000 units long. And so I just wanted to show the structure of some of these materials to highlight some of the differences in what these repeat units can look like. And so some of the small molecules that you might be familiar with, like water that we drink, or even some of the drugs that we take, like ibuprofen, don't have repeat units. These are just a single molecule that make up, say, like the pill of Advil that you take. Whereas polymers, on the other hand, like I said, have these repeat units, and we typically depict these units using these brackets because it's this one unit that repeats over and over and over again. And I think these two materials, one of which is Kevlar and the other natural rubber, highlights that these repeat units can vary, they vary significantly in the structure. And that actually then has an impact on the properties of the materials. And so to make polymers, you can think about starting with one unit, just one single unit, and having a lot of them. And these are called monomers because it's just a single unit on its own. And then you can think about two of these units coming together to form a pair. And then these pairs can come together to form shorter chains. And then those short chains can come together, and so on and so on. And you build up a really long chain molecule that we call polymers. And so you can imagine by changing the monomer structure, you can get different polymers, and these different polymers then exhibit different properties. And some of these properties that we think about as chemists and material scientists are things like their melting temperature, their toughness, and how durable they are, because these have implications for what type of applications the materials can be used for. And so chemists spend a lot of time thinking about the types of monomers that we want to use to make these different materials. And so with this in mind, and we have these well-established different types of polymers, their structure not only changes their properties, but it also changes how they can be broken down. And so when we think about the use of plastic materials in daily life, it's not necessarily that the materials themselves are the problem. The problem is how we deal with the materials after they're done being used. For example, a significant amount of these materials are discarded in the environment. And so the overall goal for chemists, other scientists, and just the general public would be not necessarily to just completely eliminate plastics from use, but to change the way that we deal with them after we're done being used. And to think about that, we can think about the different structures of the different materials to cater the way we deal with them after their use, specifically for each different polymer. And so looking at what happens to the materials as they're made and after they're used, I wanted to just talk briefly about some of the different ways or the different things that happens to plastic materials when they're done being used. And so looking at the starting point, which is of course the monomer materials that we build the polymers from, you can polymerize these together to get to a polymer material that you then form into some product, whether it's your milk jug or the automobile part, for example. Now, a significant amount of this material is gone towards either going into a landfill or thrown away in the environment. Over 70% of these materials go into the landfill. And so the scale that these materials are produced is so large that it's really difficult to really just comprehend how big of a problem this is. And so this image is just water bottles produced in the last 10 years alone next to Manhattan. And so water bottles don't even account for all of the plastic materials that we've made. And this is just a really unfathomable amount of material when put into perspective. And so 70% of this material has gone just straight into the environment, whether it's in our oceans or directly into a landfill. And another 14% of that material is actually gone towards combustion. And so what that means is that people or research groups and companies go to, and actually burn this plastic material and try to take the energy that's used through combustion and apply it towards something potentially useful. And the example that I have here is burning plastic to make electricity. And so that might have some pros to it, but there's a lot of cons and drawbacks actually to this process, specifically that the combustion of the plastic materials leads to a significant amount of greenhouse gas production. And so while it might be a short-term benefit to utilize these plastic material, this plastic waste towards energy production, the long-term impacts of that is not sustainable. And so the other approach would be to recycle this material. And so I'm sure everyone knows in some form or another what recycling means, but there's actually some nuances to it. And a lot fewer things actually get recycled than it may seem. And so this process involves collecting the materials through, say, the recycling bin, sorting them, cleaning them, separating them, melting them down, and then remolding them into new products. And within this general umbrella of recycling, there's a few different classes of different types of recycling. The first of which being what's called primary recycling. And this is probably what you would first think of when you think about recycling. And so this is when you take a plastic material and then recycle it into something that can be applied in the same type of application. And so this is actually done on only 2% of the polymer waste that we produce. And the other type of recycling is secondary recycling. And this is when the polymer that you get out of the recycling actually has lower qualities, and then you have to make materials that have lower value applications. And so for both of these examples, some of the key challenges have to do with sorting the materials, and then the fact that these materials have worse properties after the recycling process occurs. And so to talk about the first challenge here is the sorting of the plastic waste. This may seem like a trivial challenge, but it's actually quite significant, because when you just throw recycling into the recycling bin, all of this stuff, even if there's food waste or trash mixed in, has to get sorted by hand. It has to be very extensively washed in order to be even processed further. And all of this adds up to be quite a very expensive process. And oftentimes it's actually just cheaper to make new plastic than it is to recycle existing waste. And that has implications as for the motivations of recycling. And so you might wonder why we actually need to sort these materials and why we can't just melt it all down and make new materials. But you can think about different types of plastic, actually like oil and water. So if you have, say, polyethylene, which is one type of plastic, and say polyurethane, those don't mix. So the way that oil and water separate, you have what's called microphase separation. And so they actually, when you melt them down, form these domains of different materials, and then that overall reduces the actual properties of the materials, and you can't really make anything out of it after that.
Nico, can I ask
Yeah.
a question about that? Is
Yeah,
that
absolutely.
sort of separation at all used, like the melting separation used at all in the separation process? Like,
Yeah,
you
it's a
can
good
hand
question.
sort, right? But then if you can get to a point where they're melted and the two liquids will kind of form two different phases, is that
Yeah,
part
it's a
of the
great
recycling process?
question. Great question. It actually is not, because this separation it happens on the microscopic level. So you end up with what's called a bulk material that has micro domains. So you actually would still get one plastic, but this is actually what this image is depicting. So within that one plastic, you have small little regions of one type of plastic and the other, and you then lose basically the properties for both types of plastic. One thing that is used in sorting, which I'm not touching on here, is actually called density separation. So that's when you literally just float the plastics in water, and some of them float and some of them sink, and you can separate them that way. But there's still some logistical challenges that you have to overcome to do that.
Cool,
But
thank you.
it's a great question.
Thanks.
So the other challenge that I talked about was that plastics lose properties when you melt them and remold them. And so oftentimes we think of an analogy to the way that we can melt chocolate, for example. So when you first make plastic, just from monomers to polymer, the material behaves like chocolate, in the sense that you can take that material, you can melt it, and then you can mold it and cool it down, and you'll get your chocolate bar. And if you take that chocolate bar and melt it again and then remold it, you'll still get the chocolate bar. But something else that doesn't behave like chocolate, you can think about, say, the way an egg behaves when you heat up an egg. So if you have, a raw egg and you heat that up, you get a different thing that comes out of it, right? And if you cool that down, you're not going to get the raw egg again. There's a chemical change that actually happens when you heat it, so that the properties of that material changes. And so when you first make plastics, they are like chocolate, and then as you use them in their different applications, slowly there's chemical reactions that occur on the plastic surfaces that then converts it to what you can think of as starting from the chocolate into, say, like an egg. And so the problem then for trying to recycle these waste plastic materials is that when you heat them up and then cool them back down, the properties are very different. And so that's why a larger fraction of the recycling that we saw was gone towards secondary recyclings. So you would process them, and then they would have to go towards some lower value application. And so when thinking about things that require like high purity, like a water bottle that you're going to drink out of, it's more challenging to do this type of recycling to get to a new pristine material. And so an alternative type of recycling to what's called mechanical recycling, which we just saw, the melting and cooling, is chemical recycling. And so this is when you take the plastic material and then convert it back into the monomers. So then you now have these small molecules that you can make new polymers out of from the same material. But instead of actually trying to transform the polymers, you can take them back to the monomers and make new virgin polymers. And some of these, some plastics that exist do have this technology. So PET is, the plastic that you might be familiar with. That's what all like plastic water bottles are made out of. Chemical recycling is possible for PET. And I have the structure of that polymer here. And so again, you have these brackets that show the repeat unit. And I've highlighted the monomers in this case in different colors. And so for a polymer like PET, there's a bond, a chemical bond in this material that's very ready or primed for breaking that bond. And that's what I've highlighted here, this carbon-oxygen bond. And so this bond can be broken, and so you can get two monomers out of this. And so the depolymerization process is a known transformation. But this actually isn't done commercially because there's a lot of logistical challenges, again, that we have to overcome practically in order to be able to do this on, say, like an industrial scale. And again, sorting is like a massive limitation of being able to get clean material that we can then depolymerize. And it's also, with current technologies, quite energy intensive to be able to, collect, sort, clean, and then undergo this bond cleavage reaction. And again, the cost is a really high barrier that we have to overcome. And so that highlights some of the current, like I'd say, state-of-the-art recycling processes. And I just wanted to briefly touch on some ongoing research in both trying to design new polymers that are more readily depolymerized to get some sort of circular economy for polymer use rather than a linear economy. And the other of which is upcycling of plastic waste, which is taking waste material and turning it into a new material that has some actual higher value, which is my own research. And so I just wanted to highlight one example of designing new materials that can replace potentially in the future existing materials that can now be recyclable, and one of which was published last year. And this research group designed this material that behaves like polyolefins. And so polyolefins are a class of plastic materials that are used for plastic bags, other types of packaging. And this is because they're very, very strong materials and they're stable at high temperatures. The problem, though, is that unlike PET, there's no real bond here that's ready to be broken. And it's very difficult to depolymerize these materials. And so this research group designed these new materials that you can see look pretty similar, despite the fact that they just have oxygen atoms in this repeat unit. And so they similarly exhibit really strong material properties and stability at high temperatures, but they're actually very readily degradable. And I just wanted to highlight a picture from this publication that I think illustrates how cool this is. You can take a mixture of a wide variety of different waste plastic materials, and without sorting them, just putting them all into a flask here and heating them up over a catalyst that they developed, you can then collect, as you see here, pure monomer. And so they made these polymers. This PDXL is the polymer that they designed from the monomers that they designed. And in a mixed waste stream, they can cleanly get out just one single monomer. And then that can be repeated over and over again. And so they've shown that you can make recyclable polymers that can be separated without sorting. And I think this is a really exciting example of some of the research in this direction. And so finally, I wanted to just talk briefly about some of my own research towards the upcycling of plastic waste. And so what this process entails is taking waste plastic, so the polymers in waste plastic, and modifying them in some way, specifically through a chemical transformation. And so you can see here that we take these monomer units and we change just a small number of them into, in this case, the green monomer units. And from here, we have now chemical handles that we can change materials to get to some new material that could potentially serve a new application that the waste material wasn't previously able to do, or even potentially break down the plastic at these different sites to get to other types of feedstock chemicals. And so the key question and challenge that myself and my research group is really focused on is the question about how to actually perform this transformation of taking waste plastic and somehow modifying it through a chemical transformation. And so to do that, my research group has previously focused on actually introducing oxygen containing oxygen atoms onto the backbone of polyethylene chains. And so these polyethylenes are strictly hydrocarbon materials, and introducing oxygen atoms actually increases a lot of the properties that we see in these materials. And this is just some of the data that we've observed. I won't go into too much detail of the data, but basically it's that the chemical transformation to introduce oxygen into these materials has profound impacts on their properties. And so my specific research is to focus on the chemical transformation, not to introduce oxygen groups, but nitrogen groups, because nitrogen atoms have very different properties than oxygen atoms. And so we hypothesized that introducing nitrogen would have even greater increase in these properties. And so just to finish up, I just wanted to touch briefly on sort of how an individual can make a difference in this kind of picture of plastic recycling. And it might seem sometimes daunting that will my individual recycling really make a difference? And I think some of the most impactful ways that an individual can make a difference is through actually political pressure. Because if you recall throughout my talk, I think a lot of the challenges actually come from economic incentives or political incentives, because some of the technology does exist. There just doesn't seem to be, like I said, incentive to do so, whether that's politically or economically. And so I think in any way that an individual can do so, like voting and participating in local government, as well as potentially developing local programs to improve the collection and sorting of these materials, because that really is one of the greatest challenges with the state-of-the-art technology that we have. And with that, I'm happy to take any questions that anyone has.
Great, thank you so much, Nico. It looks like we've already got one question in the Q&A. For all of our attendees, please feel free to add your questions either in the chat or Q&A, and we will get to them. But our first question is from Joseph, and he was asking how color is added to plastic and whether it makes recycling plastics more difficult.
Yeah, that's a great question. So color is typically added to plastics through the addition of small dyes. And so a dye is actually just a molecule. And so that's actually mixed in, and in the plastic melt, you can add in the dye molecules. And it actually does make recycling much more difficult. And oftentimes that leads towards downcycling, so secondary recycling. Because if you mix together a lot of different types of plastic with different colors, you're likely just going to get a black material out. And it's really challenging to separate the dyes from the plastics. And so you're not going to take a water bottle and then make it with recycled plastic that's now black. And so it is a big challenge. And there are research initiatives to figure out how to remove dyes from plastic materials.
Cool, thank you. And we have another question coming in asking, do you think the production of materials with circular economies will ever outcompete polyolefin production?
Another great question. I think it's going to take policy and legislation to do so, because polyolefin production comes from crude oil. And oftentimes, actually, the monomers that we make polyolefins from would otherwise be burned. Not even for energy. They would just be burned as a byproduct from gas production. And so in some ways, plastics actually act as a carbon sink for this otherwise wasted material. And so I think in order for this to happen, there would have to be significant changes in legislature. But I think that's the goal.
Hopefully one day. And Sally is asking, should I bother with taking labels off plastic or just spend that time on activism?
Well, I think everything helps. So I don't think I would say don't take off the label anymore. But I think finding ways to potentially, like I said, a local program to improve collection systems would be a really great way to make sure that you didn't waste your time taking off the label. So that, because if you do take off the label and then it goes back into this mixed stream of recycling, it gets lumped in with everything else. And so I think every effort is a good effort, but I think activism is potentially a more impactful way.
And then we also have a question from Tom asking whether other countries, such as China, have better classification systems of plastics.
I don't know if I would say better. Oftentimes the classifications are done through the actual polymer structures. I think the question is, what do we do with the plastics once they've been classified and sorted and whatnot? And I think the biggest challenge really is collection and sorting.
Great. And I'll leave a minute for any last minute questions to come in, but if I may ask one of my own, obviously monomers already have a given structure. So when you are doing research as to how to upcycle these sorts of materials, do you kind of already know what the options are for what you would upcycle them to, and you're trying to figure out how to get to that structure? Or is there still a lot of research on like what you can even upcycle them to?
Yeah, it's sort of like a back and forth. So we do sometimes set out to achieve a goal, and in that process we might have an accidental product that we observe, and then we run with that and kind of pivot, and then through that process we find another side product, and that's what's really great about research, is especially academic research, is that it's flexible in the sense that you can have a target and be able to pivot and continue to learn what direction you can take things in.
Well, all right, and then our final question answered live, but if you have more going forward, you are free to ask them in the chat, and I think if Nico sticks around, he'd be happy to answer in the chat box. But our last question comes from a second grader asking, what is the weight of plastic trash in the open, or in the ocean, sorry? Well,
I don't have an exact number, but it's very, very, very heavy. I think, so the Great Pacific Garbage Patch is an accumulation of a lot of plastic waste that's been thrown into the ocean. And I think that constitutes islands larger than islands that people live on. I think the amount of plastic in the ocean is, just very, very, very large.
All right, thank you so much, Nico. A really cool talk. We appreciate you. So thank you very much for being here. Our second talk is from Navya, who is currently conducting HIV research at Kaiser Permanente, and will talk to us about her work there. But she spent most of her life in Orlando, Florida, and moved here to the Bay Area in 2016, where she did her bachelor's and master's at UC Berkeley in public health. She is now conducting HIV research at Kaiser, as well as being a freelance writer. And outside of her research, enjoys traveling, live music, and spending time with her dog, Appa. We're excited to hear about her work in research diversity. So please take it away, Navya.
All right, thank you, Madison. I'm gonna share my screen now. Hopefully it works like it was.
Yes, we can see it.
All right, cool. So thanks for coming to Popping the Science Bubble. As Madison said, my name is Navya, and I'll be talking about representation and research, and using my master's research with post-traumatic stress disorder and heart disease as sort of a case study to illustrate broader trends in scientific research. So before I get into all that, I wanted to make sure we were on the same page when it came to representation in the context of scientific studies. And when we ask if a study is representative, we're asking, is our study sample reflective of the population we're trying to make inferences about? For example, when testing a new medication or treatment, researchers should ensure their study sample mirrors their target user group as best as possible. So things like age, gender, pre-existing health conditions affect our reactions to drugs and medication. So it's important that the study sample is diverse if the medication is going to be widely used once it hits the market. So the research I conduct isn't biomedical, it's public health. So it rests at this unique intersection between biomedical research and population health research. So our response to exposures like germs, pollutants, etc., it differs according to factors like genetics and diet. And these sorts of things are individual risk factors for health. And we can address some health problems in hospitals and clinics. A broken arm, for example, is an isolated incident that's relatively easy for caregivers to handle. But as we know from group and population-wide exposures like the COVID-19 pandemic, not every health issue is just contained to one individual. So we need a population health lens to improve individual health outcomes. And especially when we consider preventative health and large-scale programming, population health is really important in informing these policy decisions. We couldn't have addressed the pandemic without both individual and a population health perspective. For individual health, scientists studied the virus's effect on human biology and also its transmission, its disproportionate impact on certain populations, and how to best deploy large-scale testing and vaccination initiatives or contributions from the public health field. Another important concept from public health is social determinants of health. These are conditions and places that we live, learn, work, and play that affect a wide range of health outcomes, ranging from mental health to infectious disease. You can contrast social determinants of health with individual risk factors that influence a risk for disease or vulnerability to disease or injury. So before I move on, I wanted to take a minute and kind of get you guys thinking in a public health lens and think about social determinants of health. You can just think about them in your own head, or you can throw them in the chat. I think it's hard for me to see the chat when I'm sharing my screen, but let's see if
I can read them to you as they come in if you'd like.
Okay, yeah, that'll be cool. So feel free to share and just thinking about living in working conditions, environmental conditions that operate on that population level.
Someone adds to the chat, street safety.
Yeah, street safety is a really important one.
I would assume how many people anyone sees in a day. Would that contribute at all?
That's
Or
interesting.
how isolated?
Yeah, okay, yeah. Social isolation definitely is a social determinant of health. It's interesting too how the idea of belonging, there was some research coming out of Berkeley that it affects physical health outcomes in addition to mental health. So if you're curious about that, I would check out the Othering and Belonging Institute. They do some really interesting work about how belonging affects all sorts of other outcomes.
Okay, I'll check that out. Thank you. We also have in the chat green spaces, access to grocery stores, food insecurity, how stressful your work is, as well as housing.
Yeah, those are all great examples. And now that you're all thinking in the public health way, I have an example that'll tie it all together with one that's close to home, I think, for most of us. And here's the BART map. And there's some health and wealth inequities that are overlaid on top of it. And there's a lot of information going on in this graphic. So I just want to draw your attention to two things. The first is that there's an 11-year difference in life expectancy between Walnut Creek and 12th Street, Oakland City Center BART. The second is that childhood asthma hospitalizations near 12th Street, Oakland City Center vastly outnumber those in any other geographical location. And for those of you who aren't familiar with the East Bay, these areas are pretty close together, but they have huge health disparities, as we can see from this graph. And the thing that I want you to take away from this slide is that, yes, there are individual risk factors that affect our life expectancy and whether or not we have asthma, but it's more likely that there's something operating on the population or environmentally that affects people on a large scale. So social determinants of health matter when it comes to treatment, but especially when it comes to prevention. And with that, I want to transition to my research question. What is the association between cardiovascular disease and PTSD diagnosis among adult civilian populations? There's a lot going on in this question, so I'll take a few moments to dissect and break it up, as well as illustrate why it's an important public health question to be asking, as well as link it back to social determinants of health. So the first component, and that's supposed to be a graphic of a heart. I think the Mac to PC transition didn't work well, so just pretend it's up there. But heart disease is the leading cause of global mortality, which makes it a pretty big public health issue. And there's a lot of things that can affect your risk for heart disease, but I was interested in the mind-body connection. So how do brain disorders affect our body's ability to function? Post-traumatic stress disorder is an anxiety-based disorder. And we know that anxiety triggers our fight or flight response. Things like palms sweating, your heart beating really fast, that involves the circulatory system in the short term. But I wanted to know what this meant for long-term health outcomes, such as cardiovascular disease. Diagnosis is the third part of the question, and it's really important to highlight the fact that not everyone who has PTSD is diagnosed. Diagnosis is determined by social determinants of health. So you can think about access to healthcare and mental health stigma surrounding these issues as possible reasons why people don't get diagnosed, even if they have PTSD. Lastly, I focused on civilian populations because the link of cardiovascular disease and PTSD was heavily explored in military populations, but there are some non-military populations that experience PTSD too, and some of them at comparable rates to military populations. So I was really interested in seeing what the literature was like amongst these civilian groups and what exactly they studied and how they went about it. And you may be wondering, or you may have some idea of some of these groups who are at risk for PTSD. There are, of course, the military populations, which I think is one of the most common groups that are associated with PTSD. But there's also survivors of natural disasters, immigrant refugees, and survivors of medical emergencies. And this isn't an exhaustive list by any means, but I picked some examples that were pretty different just to get you thinking about how some of the social determinants of health they face can affect their diagnosis and treatment of both PTSD and cardiovascular disease. So to answer this question, I conducted a systematic literature review. And as I mentioned before, I wasn't so much interested as conducting my own study on a population as I was seeing what other people had done, evaluating gaps in the literature, and just understanding what kind of methods people used. So I used a literature review to answer this question. What research was conducted regarding the association between PTSD and cardiovascular disease, and what are the findings? So I went back into medical databases like our research databases like PubMed and found papers that looked at this association in civilian populations. And I was, of course, interested in this association between the two conditions, but I also was interested in what kinds of studies were conducted and what populations were included. So now I'll talk about what I found. And to answer the main question, I did find an association between PTSD and cardiovascular disease, and I expected to. In doing research, it's not enough to sort of expect or even if you expect something, you kind of have to go through a lot of hoops to justify it, which is what makes good science. So that was good and well, and I finished that. But I think the most interesting thing to me was the representation part of it, which I'll spend the rest of the talk discussing. And what I expected to find was research done on cardiovascular disease for most, if not all, of the at-risk groups that we discussed. So there's a long list of civilian groups that are at disproportionately high risk for PTSD. And of course, the groups aren't mutually exclusive. So I kind of had in my head, like, okay, there's all these groups that are at high risk for PTSD. There's probably going to be a lot of studies looking at their risk of cardiovascular disease too, because again, it's the #1 cause of global mortality. But that's a little bit different than what I did find. So in this first column, the included at-risk groups were World Trade Center survivors, Hurricane Katrina survivors, and Siberian refugees. The number in parentheses is how many papers I found that included these at-risk groups in studies looking at PTSD and cardiovascular disease. And then I want to put some examples on the right of at-risk groups that weren't included. So Indigenous North Americans, refugees resettling in America, and survivors of gender-based violence. Again, not an exhaustive list, but I expected to see some studies evaluating how PTSD and cardiovascular disease were associated in populations on the right, as well as the left. And again, bringing it back to social determinants of health, we can think about how refugee populations, for example, have different access to healthcare and different ways of navigating healthcare in the US than, say, people who were survivors of Hurricane Katrina. So even though the exposure of PTSD and the outcome of cardiovascular disease is pretty, well, I don't want to say it's pretty medically standardized, but it's a similar, there's similar medical conditions enough that we kind of equate them in the medical system. The social factors that surround these populations is so different that I think they merit their own studies. And just taking a bird's eye view from this case study, I kind of became very critical of what we see in published literature after conducting this research, which was for my thesis. So I did some independent work into why we see what we see when it comes to research that concerns human beings, especially biomedical and public health research. And I'm still trying to figure it out and learn more about research and like philosophy of science type topics. But I came up with 4 points that can be used as sort of principles of thinking about where the incentives are when it comes to science and general trends. And I think they're pretty useful in thinking about science as a whole. And the first thing I wanted to bring up is that who conducts research affects what we investigate, who we study, and how we interpret the data. So in addition to having a diverse representation of the populations we study, it's also important to have diverse scientists, because we lose a lot of perspectives and knowledge about the world if we're not prioritizing diversity and representation in science. The second thing is data availability. And this might be something that if you haven't done research, you hadn't really thought about, and I certainly hadn't before I started doing research, but it is a lot easier to do research on data that's already collected. So military populations, for example, have huge historic health records because of the Veterans Administration, the VA hospitals. And it's relatively easy for researchers to pull that data and use it in their research than it is to, say, go out and collect the same data for groups like refugees or survivors of gender-based violence. I found through my research that even World Trade Center survivors have had longitudinal data that goes back to the incident that happened in 2001, and they're still tracking health metrics. And I think that's awesome because it gives us a really good picture of those health outcomes and how over decades your risk can change for different health outcomes based on a traumatic event. But I think it's important to remember that that data availability is a factor when we think about what ends up as published research. The third thing to think about is funding. And no matter what an individual researcher wants to do, if they can't secure funding for the research, it's not going to get done. And it's up to the funders, whether they be government organizations or nonprofits, what gets studied. So just thinking about monetary incentives and how they link to science is super important. And the last thing is that even among research conducted, the editorial judgment of those working in journals affects what becomes published peer-reviewed research. And you may know that some journals are more prestigious than others and are more likely to get quoted in media. So that's important to consider as well, because the more prestigious or renowned the journal is, the more strict their guidelines are probably going to be. And it's important to remember that those publications have certain constraints that do affect what we at the end of the day see as science. So I say all of this not to discourage you or to discredit science by any means. I still practice science, and a lot of these concerns definitely follow me to work every day. But I did bring them up because I think it's important to be critical about science if we want to continue to use it as a tool to learn more about the world and, most importantly, help others. And like Nico, I want to leave you with some takeaways of things you can do in your own life to address this issue of representation and research. And the first thing you can do is question what's missing. So when you read about studies or hear about them, think about who the research involved and who it's for, but then also think about what's missing. If a study claims to say that drinking caffeine cures cancer or like prevents cancer, look at who they studied and who the study may have excluded, and make sure that if they're making claims about the general population, they are in fact having a representative sample. And also just think about the social determinants of health. Many people are excluded from studies that are pregnant, for example, or that have drug dependencies, but the study authors often generalize it to the main population. So just being really critical about who's missing from studies is a good first step to take. Second thing you can do after thinking about these issues is talking about them. Everyone should care about their health, and everyone has some experiences with it. We should all discuss kind of what these experiences mean to us, and that way you can share your perspective, and by hearing from others, it can help you put your own experience into perspective as well. You can get insight onto some of the stuff that you didn't even think were social determinants of health. I think in the chat, if I didn't study public health, there's some things that I wouldn't even consider social determinants, but because we experience the world and everything kind of affects our bodies, we're discovering new things that affect health every day. And the way that you learn about them is to discuss them and raise awareness about stuff that you think is important. And that brings me to my last point, is to think about how to make what you do, whether it's owning a business, raising a family, whether you're still in school or working on any, or in a capacity on a team, just making it more inclusive. I think if your knowledge of the world ends at your own perspective, you'll really miss out on a lot. And especially in your line of work, if you're working with and for others, I think it's important to broaden that. So I'll leave you with that. And thanks for coming and listening to my talk. And yeah, I'll be around for questions.
Thank you so much, Navya. That was really cool. I'll wait for the questions to roll in, both in the Q&A and chat. But if I can kick off, I was wondering if out of the studies that you found through the link of PTSD and cardiovascular disease, I think half of them were in one category. If those studies, or most of those studies, made a conclusion that none of the other studies found, basically due to their type of PTSD.
That's a good question. Every study that I found found a positive association between the two, but I don't remember if there were certain studies that had a stronger correlation based on their group. But that's a good question.
Okay. And Tom is asking, do you have sources for social health data or the US Census, etc.? But just like, where can we find kind of what are your go-to sources for public health data?
Yeah, that's a good question. It definitely depends on the research we're doing. I think for this project, I did use, I think I looked at the CDC to see like what rates of PTSD and cardiovascular disease were like. And then for the different groups, I would just look at published research, which it's really unfortunate that it's kind of gatekept. If you're not affiliated with an academic institution, finding publications is really hard. But when I conducted this research, I was able to go in and find research on groups that were disproportionately at risk for PTSD. And then I think Kaiser also does dashboards for various, I think they were doing a COVID dashboard. I don't know what else they have surveillance wise, but CDC does a lot of dashboards as well.
Cool. And we also have a question asking, how do you or how does one secure funding for underrepresented populations if you'd like to kind of add their data to the pool?
Yeah, that's a really good question. I think securing funding is one of those things that's like the bane of every researcher's existence. And PIs, I think it's becoming more recognized in the scientific community that that looking at underrepresented groups is important. But the way you have to do it is justify, if you're applying for like a mainstream grant, like an NIH grant, I think you just have to justify that the research that you're doing, if this underrepresented group is a small group, it has like a really large magnitude, and just make your case on why this research is more important or as important than a lot of the other research that's happening, which is really difficult to do. Because I'm not a PI myself, I've never had to apply for grants. I just know from working with and editing grant application, that's kind of how it goes. There are also, for the non-mainstream, like very specific grants, there are grants that will fund specific kinds of research, and depending on your research question, you might have better luck pursuing those. But then again, I think it's knowing, it's having that experience of looking at a social determinant of health and being like, this isn't studied in the literature at all. Let me make a case for it and justify it to prove that it's an important issue. But then it becomes this chicken and egg situation, because if there's not already published research demonstrating that it's a health issue or that it's important, then you're going to have a harder time justifying why it is important. And I think that's one of the largest challenges, and something that I found in the research that I did for my thesis and that I talked about in this talk, was like a lot of groups didn't, even though they had high rates of PTSD, the kinds of studies that were done were like, for example, qualitative, and they weren't seen as valid as, say, like something like a randomized controlled trial, or something that is seen as like, I guess, like harder science than something that's qualitative.
Great. And someone has written in the chat, I think in response to your answer, that they think San Francisco has a great free grant library, only one of two in the US. I'm not entirely sure what a grant library is, but perhaps as a resource, I don't know, either for learning about disease or for some of this, how to get funding. And then someone is also asking, given the recent news on gerrymandering in LA, how can we disrupt harmful social determinants from self-perpetuating?
Well, I wish I knew the answer to that question, because then I would pretty much be able to save the world. But it is a good question to ask. and to think about, because if we don't ask those questions, the problem won't get solved. And I realized I didn't actually answer the question, but I think, and someone asked me the other day, like, you know, if it were up to you, how would you solve homelessness? And I'm like, you know, I don't know, but I think there are ways that you can think about how smaller, I'm trying to think about how to word this so it's clear, because I've struggled to express myself about this topic a lot, but there's so many things that affect a topic like housing, where, you know, we have injection drug use and also like high costs for hospital bills to like all these things. And I think if you find one area where you're like, okay, this is a lead, like this is something that is a direct correlation with this outcome, such as homelessness. Like, for example, a lot of people who are unhoused had to pay like really hard or really high medical bills, then you can like work your way up to that root of the problem and try and tackle it that way. Another thing, and just like Nico mentioned, it's really important to advocate for what you think policy should be. And also getting into organizing. It's easier if you're part of an academic community already, but if you're not, I think depending on where you live, especially if you live in the Bay Area, I don't know about LA, but there's groups here that are always like pushing to make positive social change. And I think those are some of the ways that I can think of, but it's a really big question, and I hope someone finds the answer to that soon.
Seems like there are a lot of angles to attack from. We'll all just kind of try to chip away at our little niche. And then maybe our final question, currently live here, is someone asking, they have the impression that cardiovascular disease is different between men and women. Did the studies you look at have a representative number of each, but specifically of women?
Yeah, that's a good question. Some of the studies that looked at the general population, which I didn't include here just because it was about kind of the difference in groups, but they did just because they try and standardize based on gender. And then if they don't have an equal sample, they'll do standardization after the fact to account for the fact that like certain ages or certain genders will be over and underrepresented. I don't remember reading in any of the studies that there was an overrepresentation of one gender, but it is a good question because as we know, there is a disparity when it comes to cardiovascular disease, like men have higher rates than women do. But yeah, I don't quite remember any paper that had so much of a disparity that it was like a statistically significant issue.
Cool. Okay. Thank you so much, Navya. I think that'll kind of conclude our live talks for the evening. So another round of thank yous both to Nico and Navya. It's been so exciting having you here. I think next month will be our last seminar of the year, but you can hear about either resources from this talk if you're still interested, as well as all of our future talks on our listserv, a link to which, or to join, which I have just put in the chat. But we're so thankful that you've come here tonight to watch these talks and participate with us. So thank you to our speakers and also to our audience.
Thank you so much. Thank you, everyone. These were both great talks. Learned so much, and it's just always such a delight to host Popping the Science Bubble. We keep our Zoom link the same month to month, so please tune in again. If you're looking to share the talk or view the talk again, it will be coming out soon on YouTube. So thank you so much. Have a good evening.